Let's just continue with the next talk. So, what? That's not quite. I think this is not quite you, right?
Different ginger.
Yeah, he looks kind of remotely similar. Yeah, I think this is
there
better.
You go.
I think you're just going by hair color here.
That's probably just the glasses.
Yeah. So, would like to introduce Daniel Votipka, a PhD candidate at University of Maryland, and he's going to talk about how we create defenses in software and how hackers go about that. And that is kind of your ongoing research work, I think. Please.
Okay. Let's see if we can get these slides. Give it a second. And wait for you guys. Okay, cool. Well, thank you for that introduction, and good afternoon, everyone. As you said, my name is Dan Votipka. I am a PhD student at the University of Maryland, and today I'm excited to talk about some work that we've been doing, talking to hackers or security experts and testers or non-security experts about how they look for vulnerabilities in software. So we can all agree that whenever any new code is written or modified or any changes are made, we want to make sure that there aren't any vulnerabilities introduced that an attacker could potentially use to exploit your systems. You don't want that code to actually go to market. But how do you go about doing that? Well, you could ask your developer, make sure you find all these vulnerabilities, or maybe you have a testing team who's out there trying to find these problems, but they generally don't have the expertise necessary to find these issues. So there's been a lot of really interesting research looking at this. So they're generally your generalists. They focus on sort of everything from functionality, performance, security. Again, not security experts. But there's been some prior research sort of trying to figure out how good testers and developers are at finding problems. So there's a group, I think out of Berkeley, Edmondson et al., who did this study where they had 30 developers looking at a web application, trying to find, they'd introduced a bunch of different vulnerabilities, your basic stuff, cross-site scripting, SQL injection, things like that. And even with all 30 people looking at it, they couldn't find all the problems. There were still several that were just missed. Even though they had a large number of people, a lot of development experience, and these were pretty simple issues. In a similar study by Oliveira et al., they had, I think, around 200-300 developers looking at small code snippets that had vulnerabilities in them, asking them to find these problems. Same thing. Couldn't find a lot of these issues, especially when it came to APIs that were performing some of these security behaviors. And then in some recent work that my colleagues and I have been doing, we had participants in a sort of security course who were professional developers. We put them through a couple months long training in security. We had them then go build these sort of medium-sized software from scratch. We told them you need to fit these security requirements, and still lots of different errors that came out of that. So relying on our sort of developers and testers who don't have a lot of security experience, even if we're sort of teaching a lot of this in sort of basic training, can be difficult. So what else can we do? Well, this brings us sort of to the theme of this conference, which is let's embrace the hackers. You may have also heard another sort of cliche term of adopting an adversarial mindset, thinking about things from sort of this, as if you were the attacker, what could you do? But the big question for this is, well, how do we do that? What does this adversarial mindset even look like? So one sort of obvious way you could do this is just go hire a bunch of hackers. So you can bring people in on your security team, hire pen testers, or what's sort of becoming the rage, reach out to large crowds of hackers in bug bounty programs. And this is actually, I would say, beneficial. There's several benefits to this. One, you get sort of responsible disclosure. If someone finds a problem in your code, they can give that to you, make sure they can fix it. You sort of take advantage of this sort of ethical approach to trying to find vulnerabilities, that people's sort of good nature. But you also get a ton of extra eyeballs, which I would argue is actually very important when it comes to trying to find vulnerabilities. There's been a lot of research looking at this. So Mailer et al. Looked at all the vulnerabilities that have been reported on HackerOne, which is a large bug bounty as a service platform. And one thing they found that was really interesting was that each security researcher can only inspect the discover a bounded number of bugs. And they postulated that this is because each researcher inspecting a piece of software offers a unique skill set, or offers unique skill sets and mindsets, amenable to the discovery of bugs others may not be able to uncover. So basically, having a different way of looking at things is really important, and getting as many different views into the system is really the key here. In a similar study, Finifter and their group looked at the bug reports for Firefox and Chrome over, I think, a couple-year period. And those reports include both internal and external submissions, so both from the company and from their bug bounty programs. And what they found was that 27% of Chrome bugs originated from the bounties, and 24% from the Firefox system came from the bounties. And this is sort of in the early days of these programs. As they sort of went on, they found that the external contributions, so those are the bug bounties, for Chrome actually almost caught the internal contributions. So you're seeing a lot of different contributions from the bug bounty, a lot of value there. One of the really interesting things from this research is that they saw that the cost of either of these bug bounty programs is comparable to the cost of just one member of the browser security team. So that's a really interesting finding. One caveat here, they're comparing the cost of sort of one person's salary versus the payouts for the bounty, not all the other costs as far as triaging these reports. But still, that one person comparing to basically having access to this large set of people is actually very significant. So this sort of tells us that these programs are beneficial. But there are still some challenges. So even though I think this is sort of the right direction to go, getting all these people in the house, getting more people looking at it, there's still some issues. One is just the timeliness of it. So in a lot of cases, these security reviews, even if it's pen testing, or in the case of bug bounties, this is coming late in the process. You don't get to have these people involved early in the design. And as you find some of these issues, you then have to go back and make a lot of changes. And so those can be very costly. There's still an issue with cognitive diversity, so that many eyeballs issue still exists. These bug bounty programs, even though you're getting exposure to a large number of people, they tend to be, the populations tend to be not very diverse, and also the contributions tend to be from a small number of people, even though you might have a few contributions from a large group. Significant portions come from a small population. So still issues with cognitive diversity. We want to get more people looking for vulnerabilities. And then finally, communication tends to be a struggle. So if you talk to people on either sides of this, so people in the bug bounty programs, they'll tell you that they have issues just communicating the problems that they're finding to the developers, convincing them to fix things, and they can get frustrated. And then on the company side, if you talk to people who run these bug bounty programs, you hear a lot of cases of, well, we're just getting lots of false reports, and I can't understand what we're talking about. There are sort of lots of different communication barriers between these two groups. And so that's kind of what we were trying to get at when we started our research. We wanted to really understand what this ecosystem looks like. And the way we decided to do that is we wanted to look at what the difference was between the software testers, who are probably the nearest analog to hackers because they're both looking for issues in the system, and see if we could draw out what is the difference between these two and what could we learn from them to solve some of those challenges, and maybe figure out what this adversarial mindset actually looks like. So that leads us to our sort of specific research questions that we cared about. First, how do testers and hackers search for vulnerabilities? And then what are the differences between the two? And to do this, we ran a series of interviews where we had each participant perform what's called a task analysis. And this is a method taken from cognitive psychology, where you have someone basically walk through their process, and as they go through, break each piece or each step down into smaller and smaller subsets. In a lot of cases, when you have someone sort of describing their expert knowledge, they're going to skip over certain things that they just do via rote memory. So this sort of process allows us to really dig deep into what's going on as hackers are trying to find vulnerabilities. We also asked them questions about the different tools they use, the skills they needed, and the communities they were part of, to get an idea of how they actually implemented this process and how they developed it over time. So to recruit for this, we reached out to a large number of different organizations in both the hacking community and the testing community. In total, I contacted 106 groups, tons of emails back and forth, and eventually recruited 10 testers and 15 hackers for an hour-long interview. So what did we find? Well, at the first question, so how do testers and hackers search for vulnerabilities? Interestingly, we found that their process was basically the same. It sort of mapped to these 6 steps. Between all of our interviews, this was kind of the process that everyone sort of discussed, even if they used different terminology for it. And what this entailed was first sort of going through and gathering as much context as they could about the program. This included identifying different libraries, how the system had been updated over time, and looking at previous bug reports. One tester explained this, saying there were other functional issues, so I figured that was probably where there was most likely to be security issues as well, because bugs tend to cluster. So there's a lot of different heuristics they would go to sort of figure out where to focus on. Next, they sort of entered the main loop of their process, where they began by trying to understand how the program worked, understanding the different interaction between components and how it interacts with its environment, so the network, file system, memory system, things like that. Once they had a little bit of, one of the hackers described this as saying they were touching a little bit of everything, organizing it to a structure in your head, trying to build a map of the way the program works. And then once they had that map, they moved into the attack surface phase, where they're trying to identify all the places where they can provide input to the system, direct, indirect inputs, things like that. Then they would explore that attack surface, trying to pick out whatever different inputs they could provide. This was done either through fuzzing manually and automatically, as well as just reading through the code, reading through the binary, trying to figure out what could potentially be done. And this kind of just keeps looping around. So as they explored more, they understood more about the program, they would identify more attack surface space, more flows through the program, they would explore that and sort of keep going until eventually they recognized a vulnerability. So this is, as they're exploring, they notice a problem, and they reported this as being typically intuition-based. And I'll get into more what I mean by that later, but this is kind of the key thing. They keep going through and they eventually find something. And then, importantly, they actually report this. They need to tell the developers what the problem is. And the big thing here is they reported, both groups said that it was really important to advocate for the remediation. So you want to make sure the report's understandable and make sure it's important, or the importance of fixing it is clear. One of the testers said that you do have to convince someone that there's a risk. It's quite timely or time-consuming running a ticket. So actually motivating the developers is a really important piece for both of these groups, even if they were internal to the company. So they have a similar process, but what's the difference? This is kind of what we all care about. So what we found is that even though they had the same process, there were sort of 4 factors that involved, or that sort of affected the way that they actually carried out this process. The first of those being their experience with vulnerability discovery. So how many and what types of different vulnerabilities had they seen previously? The next was their underlying system knowledge. So how well did they understand the programming languages being used, the APIs, the underlying memory management of the system? Also, their access to the development process had an effect. So whether or not they were involved in the design phase, whether they had communications with the developers, whether or not they were just treating everything like a black box. And then finally, their motivation. So are they just trying to find all the vulnerabilities they can because their goal is to make sure the system is as secure as possible? Or are they just trying to find a few vulnerabilities so they can get some rewards through a bug bounty program? And what we found is these factors could be grouped into 2 categories. The first 2, actually, when we saw improvements, so the more experience they had, the more understanding of the system that they had, the higher reported success rate at finding vulnerabilities. Whereas the other 2 factors, they affected the process and how it was carried out, but not necessarily how much success they had. And I'll talk a little bit more about what I mean by that later. And specifically, these 2 categories of vulnerability discovery experience and access to development process were where the hackers and the testers, we saw them differ the most. If you'd like more details on the other sort of factors, I'm going to be skipping those for now, just for brevity. But I've got a link at the end of the talk to the actual paper we went through and discussed everything in much more detail. And so what we found is that the hackers had much more vulnerability discovery experience, and the testers, as you would expect, they have more access to the development process. They're actually embedded into the company. So what does this mean for their process? Well, when it came to vulnerability discovery experience, having more experience helped them in sort of these 3 phases most importantly. So in the attack surface, it made them more likely to consider indirect inputs. So one example of this came from one of our testers who talked about a scenario where there was an SQL injection vulnerability in their system where they were just pulling all the data from users' LinkedIn profiles as a sort of easy way to pull in their profile information. And they were just importing that straight into their SQL database without doing any kind of filtering or checking to make sure LinkedIn was processing data appropriately. And unfortunately, fortunately, they just happened to have an apostrophe or some character in one of the test files that they were using, just happened to cause a crash in the system. They figured out what was going on and realized that there was this vulnerability. It was completely by happenstance. But after seeing that, after they found this LinkedIn problem, the tester said that I made sure to test Facebook and Twitter input to make sure they were processed correctly. And if I did allow login with another third party in the future, I would check that too. So now that they've been exposed to that sort of indirect path they didn't think about originally, they now think about that going forward. We saw similar situations with exploration. So the more experience they had informed different test case selection when they were going through and manually testing these systems. And then also when it came to vulnerability recognition, this is kind of where that intuition comes from. It's just from seeing prior vulnerabilities, they were able to map, this looks like something I've seen before, let me go check and see if it's actually a problem. And actually a lot of our participants, interestingly, said that they had sort of lists of vulnerabilities that they looked for whenever they were looking at a system. This could be either just a mental checklist or in a lot of cases a physical list of, okay, it's this type of system, let me check these things. And so our participants said that they learned or they developed these through sort of these four different options. So one was through their employment, so just as they went about their day, they kind of ran into different problems as they were looking through systems, and that exposed them to new vulnerabilities. By participating in different hacking exercises, so these are things like capture the flag competition, where they're actually looking at code that's known to have a vulnerability in it, and they're trying to find out where that problem is. So they're guided through learning about new problems by just doing. Many of our participants reported learning just through their community, talking to other people about their experiences, hearing about vulnerabilities that they'd either come across by reading or through these exercises or through their employment, just sort of learning vicariously. And then finally, just by reading bug reports, so going and looking at what had happened in prior on other systems and other people's code or in their own company's code, how those bugs came about. And interestingly, what we found is that the amount of experience was really where these two groups differed. So when it came to employment, our testers are looking at one system or a few systems within their company, whereas the hackers are looking for vulnerabilities across a wide swath of different systems. When it came to hacking exercises, our testers participated in maybe one training that was put on by their company, whereas hackers went out and competed in dozens. When it came to their community, the testers maybe knew someone who was interested in security, whereas the hackers, that's their entire community. There's a ton of people who know a lot about security and are curious. And then when it came to the bug reports, again, the developer or the testers were looking internally to the company at the reports that were filed, and so you may or may not see a few vulnerability reports, whereas the hackers are looking at just sort of wide swath, reading through all the bug reports on Firefox or Chrome, or looking at all the bugs reported on each of the different bug bounty platforms. There's just this wide gap of experience and this variety where we see the big difference between these two populations. So now going on to sort of the other side. When it came to the access development process, what did this mean? So as you'd expect, our testers, they're more internal. They have the opportunity to communicate with the developers. They have access to the documentation. And this can be helpful because it saves a lot of time. The hackers had to spend a lot of time reverse engineering, trying to figure out how the system works. Really trying to dig into a lot of sort of this black box problem. But this can also be a double-edged sword. So this comes back to the idea that while access to the development process can impact the way this process is carried out, it's not necessarily beneficial, and you kind of want both sides. One of our testers said that it's hard to ignore certain details once you know about certain areas already. So once you've kind of been exposed to something, it's hard to sort of step back and think about it from a different perspective. So having both of these perspectives, both internal and external, is still really important. And then when it came to reporting, the real big success here for testers is just having that rapport. So one of our testers talked about, you can give feedback to your developers, you're coming back with information and then they react on it. So over time, you're basically building a dialogue and you have sort of this relationship. Whereas the hackers in most cases, they're having one time that they're talking to the company and they hope that they actually understand what they're saying. In a lot of cases, they're spending a lot of time building exploits, to try to prove that there's an issue. And even in a lot of cases, there's companies still sort of say, no, that's not actually an issue. This isn't actually a problem. And so you run into a lot of these communication problems. So what can we take away from this? What's our lessons learned? What can we do to help sort of embrace some of the things to help make our developers think more securely, but also reach out and work better with these hackers? So when it comes to the developers and the tester side, really the goal here is to sort of increase that experience. And so we suggest providing security exposure or exposure to security in context. So I add the in context part there because I don't imagine that all the developers that are out there going and spending a ton of time working on CTFs and playing war games online by themselves. So you want to limit the amount of additional work they have to go do to actually be able to learn about security. And so one recommendation here is just to hire a few hackers into some testing teams. So there was actually a really great story that we got from one of our testers who said that they had they brought in 2 hackers to their company. So before this whole thing, they'd had a pen testing exercise or a pen testing team come in. They found a ton of vulnerabilities. Then they decided they'd hire 2 people who weren't the most experienced hackers. They were probably had a little bit of training, sort of in the mid-level. But they brought them in, and as they worked side by side with them, they would recognize problems, say, hey, this might be this issue. Let's dig into that. They would find these problems. But they're working side by side with the testing team. Those people who were sitting next to them would learn things. They would teach that to people around them until eventually, after 2 years, they built sort of a security culture within the company. And they had the same pen testing team come back and try to look for problems, and they couldn't find very much of anything. So you see sort of success there just by having a few people involved. The other suggestion would be just to use bug report-based exercises, so taking reports from the company, so that's already built into the context of the development environment that you're working in, and building these as exercises. So we saw one of the big things that our hackers reported learning from was just these exercises, so getting hands-on experience with finding these problems that can be easily transferred into the workplace. And we're actually testing sort of this idea out at Dropbox right now. They have an internal capture the flag competition, and we're running a study around that to figure out whether or not that actually helps improve development security. The early results from that say yes, mostly in just helping build developers' understanding to point the security team at where specifically to focus. And then finally, how can we help get the hackers involved? One sort of basic suggestion is just be consistent with hacker communication. So one easy way to do this is just having a single point of contact so that whenever they're coming in, they're talking to the same person. And even if it's not the same hacker reporting multiple vulnerabilities, they're at least talking to someone who's been talking to hackers, and they can kind of know the language and translate between developers to hackers what the problems might be. And one example of why this is sort of beneficial is we saw the people who, when we were talking to hackers, the ones who had the least issues were the ones who sort of reported multiple times and kind of had already built a relationship. We had one guy who reported a lot of Android firmware problems, and he basically said, I don't need to write exploits anymore. I just sort of point to the line of code, and I can tell them exactly how to fix it, and they go fix it, and it's within a short period of time, everything's good to go. So in summary, we found that both of these groups had similar processes that were impacted by these 4 factors, but the big difference was in their variety of experience and their relationship with the developers. And so as recommendations, we suggest exposing developers and testers to security in the work context and providing consistent communication with hackers. And so with that, I will open up for any questions. I think I'm a little under time.
Thank you very much, David. A warm applause. Thank you. So questions to David, please. 2, 3. Okay, so is it a cultural thing then?
You mean
to establish a security culture in our developers?
So I think it's important to establish a culture because none of this is probably going to take hold.
Right.
because people aren't actually going to go spend the time to focus on working on these things unless you have that culture first. So there's sort of two steps. We're looking at it sort of agnostic of that problem. There's a massive managerial problem to this. There's plenty of other research that shows that you need that first, or that needs to be involved. Yeah. Oh, okay. But yes, that is another issue that needs to happen. And then on top of that, you also need to think about how you're teaching people once they're engaged.
Right. Okay. Thank you. Are there any other questions? Oh, sorry.
Oh, yeah, I was just going to say, this research is there's the link for it. This research, as well as all the other papers that we've been doing, focus on security experts. Also, if you're interested in working with us, one of the biggest struggles that we have when it comes to studying security experts is just getting people to participate in our research. So if you'd like to either work with us at running anything sort of in the field, we're doing something at Dropbox now. We'd love to work with other companies, or just participate in as interviews or surveys, things like that. There's a link on the page if you'd like to volunteer for our research panel. But yeah, check out our website.
Okay, so we can get interviewed by you. Is that
Yeah, I'd love to talk to people.
All right, super. Thanks again, David. Before we close for lunch, do we have Catherine Chapman here now? Okay. And I would like to remind everybody of our sponsors and make sure that we have that you do fill in your questionnaires and get your stamps. Thank you very much.